Okay, so you're looking to get a real handle on something important. Yeah.
Yeah.
Quickly, thoroughly, without wading through tons of info. You're busy. You need the core insights, like now. And that's what we do here. We take the source material, dive right in, and pull out what really matters.
And today we've got something pretty fascinating lined up. It's an AI system from Florida Atlantic University engineers designed to translate American Sign Language ASL into text. And it does it in real time.
Yeah, this is based on a news release from EurekAlert,
Mm-hmm.
which points to a study in the journal Sensors. So
Yeah.
our mission today, figure out how this thing works, why it's such a big deal, and what it could mean for making communication easier for everyone.
Absolutely, because think about it, there are millions of people who are deaf or hard of hearing. Communication can be a real hurdle. Interpreters are amazing, of course, but they're not always available, right?
Yeah.
So technology like this, it could really help bridge those gaps.
Definitely. And the EurekAlert piece mentioned some big challenges with older ASL recognition systems. What were those?
Well, a major one was just getting them to work fast enough, in real time. Plus, accuracy and reliability could be patchy. They might work okay in a lab, but then struggle in different settings, different lighting, that kind of thing.
Right, and they mentioned something interesting, visually similar signs, like letters that look almost the same.
Exactly. Think about the hand shapes for A and T, or maybe M and N. They're quite close visually. So older systems could easily mix them up, leading to misclassifications. It's a tricky problem.
And it wasn't just the signs themselves, but the data they learned from.
Yeah, the quality of the training data is huge. You've got variations in like image resolution, maybe motion blur if the person signs quickly. Then there's lighting, different backgrounds, even just different hand sizes or skin tones. All that variation can mess with the system's learning, sometimes even introduce bias.
Okay, so that sets the stage. A lot of hurdles. Now, the FAU researchers, they took a new approach, right? Combining AI tools.
They did. They combined YOLOv 11 and MediaPipe. And it's this combination that seems really powerful.
YOLOv 11 and MediaPipe. What do they each do?
So YOLOv 11 is really good at object detection, basically. Spotting things quickly in an image or video, in this case, spotting the hand. And MediaPipe is excellent at tracking specific points on that object very precisely. Think tracking the joints and fingertips of the hand.
Ah, okay. So one finds the hand, the other maps it out in detail.
Pretty much. By putting them together, the system can quickly find the signing hand and then track its exact shape and movement using deep learning. It recognizes the ASL alphabet letters based on that tracking and then, boom, translates it into text on screen. Useful for, say, spelling out names or places interactively.
That sounds incredibly useful. So let's dig into the tech a bit more. How does it actually see and process the signs?
It starts simple, just a standard webcam, like the one maybe built into your laptop. That acts as the sensor, capturing live video, no special gloves or anything needed.
Okay, so it's contact-free.
Nice. Yeah. Then the video gets broken down into digital frames, like snapshots. MediaPipe jumps in then. It analyzes these frames and identifies 21 specific key points on each hand.
21 points. What kind of points?
Think fingertips, knuckles, the base of the fingers, the wrist. It essentially creates a digital skeleton map of the hand in real time.
Got it. A skeletal map. And then YOLOv 11 uses that map.
Exactly. YOLOv 11 takes those key points, that skeletal structure, and uses that information to figure out which ASL letter is being signed. It's classifying based on the precise positions of those points. That's how it gets around the problem of similar-looking signs, by focusing on the underlying structure.
And they mentioned this works well even if the lighting changes or the background is messy. That seems like a big win.
It really is. That robustness comes from the AI models themselves and how they were trained. YOLOv 11 and MediaPipe have learned from vast amounts of data, so they're better at ignoring irrelevant stuff like shadows or a cluttered room and just focusing on the hand shape and movement.
And the fact it uses standard hardware, like a webcam,
Yeah.
that makes it more practical.
Hugely practical means potentially lower cost and easier rollout. It's not some expensive specialized setup, much more accessible.
Makes sense. And the performance. They had a specific accuracy number, didn't they?
They did. The paper in Sensors reported 98.2% mean average precision MAP at 0.5.
98.2%. Wow. What does that mean in plain English?
It basically means it's incredibly good at getting the letters right with very few mistakes. And crucially, it does this with minimal delay, almost instantly. That real-time speed and high accuracy are vital if you want to use this for, say, live conversations or interactive learning tools. It needs to keep up.
Okay, 98.2%. You don't get that without some serious training data. Tell me about the data set they used.
Right, the data set was key. It's called the ASL Alphabet Hand Gesture Data Set, and it's massive 130,000 images.
130,000. That's a lot of pictures of hands.
It is. But it's not just the number, it's the variety. They purposefully captured signs under all sorts of conditions. Different lighting, bright sun, dim rooms, shadows, different backgrounds, indoors, outdoors, simple, complex, different angles, different hand orientations.
So they really try to show the AI the real world, not just perfect studio shots.
Exactly that. They wanted the system to generalize, to work well even when conditions aren't ideal. That diversity is crucial for robustness. And for every single one of those 130,000 images, they marked out those 21 key points: fingertips, knuckles, wrist.
Ah, so the AI wasn't just looking at a picture. It was given that skeletal map for every example.
Precisely. That detailed annotation helps it learn the really subtle differences between signs, even the tricky ones like M and N. It learns the underlying structure, not just the overall visual shape.
Okay, so we've got this system. It's accurate, real-time, uses normal cameras, trained on diverse data. Let's zoom out. Why does this research matter?
Well, you mentioned the numbers earlier. Around 11 million deaf individuals in the U.S., maybe 37.5 million adults with some hearing difficulty. That's a lot of people. This technology offers a potential AI tool to help translate ASL into text, which could make everyday interactions smoother. Think about education, work, healthcare, just socializing.
It really boils down to accessibility and inclusivity, doesn't it? Breaking down those communication barriers.
Absolutely. And the researchers themselves really emphasize that. Badr Al-Sharif, the lead author, talked about the real-time aspect. Imad Malgoob spoke about AI serving humanity. Mohammed Ilyas mentioned transforming communication for the deaf community. And Stella Batalama, the engineering dean, highlighted how it fosters a more inclusive society. Their focus is clearly on the human impact.
That's great to hear. It's not just tech for tech's sake. So what's next for them? Are they stopping at individual letters?
No, the plan is to expand it. The next big step, according to the release, is to get the system to understand and translate full ASL sentences. Going from single letters to fluent sentences, that would be a huge leap towards more natural communication.
Definitely a major step.
Aye.
Okay, so to wrap this up, what's the main takeaway someone should have from our deep dives today?
I think the key thing is that this FAU system is a really significant step forward for real-time ASL translation. By smartly combining AI tools like YOLOV 11 and MediaPipe and training them thoroughly on a diverse data set, they've built something that's accurate, fast, and potentially much more accessible than previous approaches. It tackles a real communication need.
Right. It's a powerful example of AI being used for accessibility.
Mm.
So as you think about this, consider, what else could technology like this do? How might these kinds of accessible AI-driven tools change interactions everywhere, not just for sign language? What other communication challenges could we tackle? Something to ponder. Thanks for joining us for this deep dive.